So let's start Fourier series. So prerequisite for this course is prerequisite integral calculus. So the prerequisites for the Fourier series are integral calculus. Small integration, students should be familiar with the integration of two functions. So in introduction, let me explain. Many functions that we use in science and technology are periodic. So we use periodic function in many of the problems, periodic functions. Many functions that we use in science and technology are periodic. The first periodic function, we were having sines and cosine. Sine and cosine. These were the first periodic function we encountered. Fourier series expresses a periodic function into a series of sine and cosine. What does a Fourier series do? Fourier series expresses. So Fourier series expresses a periodic function. So f of x. Let me discuss the definition of periodic function. Suppose f of x is a periodic function. Fourier series express this periodic function into a series of sines and cosine. Into a series of sines, cosine. So Fourier series is more versatile than Taylor series. Because when we're talking about Taylor series is working for continuous function. So Taylor series is working for continuous function. When we are having a function, for example, we are having a polynomial, an exponential, or sine, cosine x, these are continuous function. We find the Taylor series for this function about any point. Fourier series works for both continuous as well as piecewise continuous function. So since we are talking about Fourier series, the functions are continuous as well as piecewise continuous. But here one of the important point to discuss is all the functions for which we are going to find the Fourier series are periodic. So we are talking about the periodic function. Fourier series expresses a periodic function into a series of sine and cosine. This is what does a Fourier series do. And you are talking about all the time we have to work with the periodic functions. And let me explain what does I mean by periodic function and how a Fourier series expresses a periodic function into a series of sine and cosine. Definition, let me write down the periodic function. A periodic function, f of x. A function f of x is said to be periodic if it satisfies f of x plus p is f of x, where p is greater than 0, a real number. So where p is the period of the function, it is a real number. This function is defined for all x as well as it should satisfy this equation. If this equation is satisfied, then we say f of x is a periodic function. For example, if I am talking about sine x, let me have a function sine x. So its period, everybody is familiar, its period is 2 pi. So if I am going to have x plus 2 pi there. And if I am going to have the trigonometric identity sine of a cos of b plus cos of a sine of b, I'll get this function back, sine of x, where p is this 2 pi, which is a real number. Let me graph the function f of x is equal to sine x, so that I'll sketch and see whether its period is pi, 2 pi or 3 pi, so on and so forth. This is x-axis, and this is, let me move on both sides, minus pi and so on and so forth. This is y is equal to f of x. If I am sketching this function by taking x-axis, some radian measures, when x is 0, f of x is 0. When x is pi, it is 0 again. When x is 2 pi, it is 0 again. Let me have in between something. Let me have pi by 2 there and then 3 pi by 2 there. So if I am putting x is equal to pi by 2 here, f of x is 1. This is 1. Sine pi by 2 will give you 1. And if I put x is equal to 3 pi by 2 here, f of x is minus 1. So sine 3 pi by 2 is minus 1. Let me draw the graph of this. So this is the graph of sine x. And you see this point is going to be there. It means after 2 pi, this is the length of the interval, which is the period, 2 pi. 2 pi, the function is going to repeat itself again like this. So 2 pi is the smallest period for sine x. Similarly, we have a couple of points to be noted. Points to be noted. So couple of points we are talking about, since we are having introduction. So the introduction will give you everything related to the Fourier series. Then there is nothing left because it is really simple, it's not difficult. Number 1, the smallest period with which a function repeats itself is called fundamental. So here the fundamental is 2 pi. Because if you say fundamental is pi, suppose for example you say fundamental is pi, then after pi the function is going to be down below the x-axis. So the same graph is going to be repeated after 2 pi. So 2 pi is the smallest period for sine x. Fundamental period is the smallest period with which the function repeats itself. Number 2, a constant function. Constant function does not have any fundamental period. Suppose if I am going to have y is equal to f of x is equal to 4. Let me have a constant function. And if I sketch this constant function, so I'll have something there, pi, 2 pi. Let me have 2 pi, something here. Constant 1, 2, 3, 4. Let me have, this is the line, constant function. So the constant function does not have any fundamental period. This you have to, the second point, the constant function does not have any fundamental period. Now, if a constant function is added, to any function whose period is 2 pi, let me have. So since this function having period 2 pi, but I do not have any fundamental for the constant, what the constant is going to be? Constant function will assume the same period as its friend. So it means if a constant is adding or subtracting, it does not have its fundamental. It will take the period which the other function have. It means two functions now having the same period. So h of x will have period 2 pi. So if you can add two functions, those who having the same period. It doesn't make any difference. Suppose if I am going to have the counter example, h of x is a function. If you are having f of x is a function plus c is there. You said its period is pi. its period is 2 pi. You cannot add them. So the constant function will attain the period of the function which is going to be added or subtracted. Then you can add them. Or two functions having same period. If let me have gx. Let me have another function gx, here f of x in a function. If I am adding, they must have the same period. If they are 2 pi, it must have 2 pi. Then this hx must have 2 pi. Because it is not the case, this has pi, this is 2 pi, you are adding them together. No. You can add only in the situation when they have the same period. This is the case. This is the third point. The constant function does not have any fundamental. So what does it do is, it attains the same period as the other function which is going to be added or subtracted. So, fourth. If f of x having period p, then number 1, f of ax having period p by a, and this other property f of x by a having period ap. Let me explain this with the help of a diagram so that you will understand how does this period is going to be in this for this function which is ax and x by a. Fundamental, so smallest the constant function to an adding, and this. Let me again have f of x is sin x. Period is the smallest, I am talking about 2 pi. Now I am taking f of x is sin 2x. According to the definition, this is sin 2x I am talking. Sin 2x. The period must be p by a, mean 2 pi by 2. 2 pi by 2 mean pi. Sin 2x must have period pi. Let me sketch. So that this is pi, this is 2 pi, this is 0, this is minus pi, this is f of x. So sin 2x must have period pi. If x is 0, f of x is 0. If x is pi, so sin 2 pi 0, again 0, let me have this is pi by 2. If I am going to have x is pi by 2, 2 cancelled sin pi is 0 again. Look, it means I have to short the interval again. This is pi by 4 and this is 3 pi by 4. So I am having 0, pi by 4. Then pi by 4 is added, pi by 2, then pi by 4 is added, 3 pi by 4, then pi by 4 is added pi. So from 0 to pi, I'll have the interval pi by 4, something like this. If I am going to have pi by 4 there, to sin, it is sin 2 pi by 4 means sin pi by 2 which is 1. Then 3 pi by 4. If I am going to have 3 pi by 4, it is sin 3 pi by 2 which is minus 1. So I'll sketch this like this. Look. So this is the period for sin 2x. Sin 2x having period pi. And this graph, which I have started from 0 to come to here and then go back and then come back to here. Look, so this graph repeats after pi and again it is going to be repeated. So similarly, if I say sin 50x, this is my f of x. What will be its period? If I am talking about sin 50x, the period will be 2 pi by 50, which is pi by 25. Pi by 25 is the period, according to the formula which we have this. So, now we are talking about this. Let me have f of x again. F of x is sin x by 2. Look at that. This x by 2 I have. So if the formula makes period is going to be the make sense like this. AP, where a is 2. So it means its period must be 4 pi. 2 pi multiplied by 2, which is 4 pi. 4 pi is the period of sin x by 2. Let me sketch again. So on x-axis is pi, 2 pi, 3 pi, 4 pi, 4 pi, 3 pi, 2 pi, pi, and on the other side I can have the same 2 pi, and this is f of x. If I am sketching, when x is 0, sine 0 is 0. When x is pi, sine pi by 2 is 1. When x is 2 pi divided by 2, sine pi is 0. When x is 3 pi, sine 3 pi by 2 is minus 1. This is minus 1. And when x is 4 pi, sine 2 pi is 0 again. So let me sketch this. This is going to be, this is 1 and this. Look at that. So this is compression of the scale and this is the elongation. It means sine 2x having period pi, which we have seen, and sine x by 2 is period 4 pi, which we have seen through the graph. So two functions of the same period you can add them. And then the function which you are getting, that will have the same period as the constant function does not have any fundamental period. The smallest is the fundamental. Let fx be a periodic function whose period is 2 pi. With period 2 pi. Let fx be a periodic function. I have chosen a periodic function whose period is 2 pi and I am writing a Fourier series. It's Fourier series. Its Fourier series can be written. Let me write down. This is a0 plus a1 cos x plus b1 sin x plus a2 cos 2x plus b2 sin 2x plus a3 cos 3x and so on and so forth. Now let me explain. Since I have taken a function whose period is 2 pi and in this function I have written a period is 2 pi, it means I am writing an infinite series, the trigonometric function. So each term must have period 2 pi. Each term must have period 2 pi. That's why I am going to add them and then this function is of 2 pi. Because in a few minutes earlier I explained, if I have two function g of x and this is of period 2 pi, this is of period 2 pi, then this function must have period 2 pi. So I have written a series of trigonometric function, but this function which is periodic, its period is 2 pi. It means cos x. What is the period, fundamental period of cos x, which is 2 pi? Sin x, period is 2 pi. What is the fundamental period of cos 2x, which is pi? But if pi is a period, can I say n pi? N pi, where n is an integer, is also a period. It means this function must have period 2 pi as well. Suppose, for example, let me come here. If f of x has period p, then np, where n is an integer, is also a period. Also a period. Look at that. So np is also a period. If p is a period, it means when you multiply with an integer, that is also a period. Similarly, sin 2x having fundamental period pi, but I multiply with the integer 2 pi is also a period. Cos 3x, the fundamental period is 2 pi by 3. Because with the help of formula we have discussed, if fx has period p, then f of ax is period p by a. So 2 pi by 3 is a period of cos 3x. It means if I multiply this with an integer, I'll get 2 pi. So this term must have period 2 pi. It means the infinite series, if I am working with thousands of x, cos 1000x, sine 2000x, still those terms must have period 2 pi after multiply with an integer. So I have written this series of trigonometric function with each term having period 2 pi. This function is the constant function will attain the period as the rest of the function. So constant function does not have its own fundamental. What does it do is it is going to attain all the period for the rest of the function. Let me write this in terms of sigma notation. N is equal to 1 to infinity a n cos nx plus bn sin nx, and this is f of x. This is n to infinity. This is the Fourier series, required Fourier series for a function whose period is 2 pi. If I say this function having period pi, can I have the same series for a period pi? No, because its fundamental is 2 pi. So if you are adding all the function of the same period, then you are getting this function having period same. So it means the smallest Fourier series which you are getting for period 2 pi. You can have 4 pi, 6 pi, 8 pi, but the smallest is 2 pi. So we are talking about a function which is periodic having period 2 pi like this. This is the Fourier series for a function whose period is 2 pi, where a naught, an and bn are Fourier coefficient. To be determined. So we have to determine an, a naught, an and bn, which are the coefficients, Fourier coefficient we have to determine. Before determining the coefficient, we'll have couple of functions. We see how to sketch. Example. Sketch the following functions. Which are assumed to be periodic. In the interval 2 pi. Interval 2 pi. Let us see how to sketch a function and showing its periodic, which are assumed to be periodic. And according to the definition, a function is said to be periodic which repeats itself in the given interval. So we have seen the Fourier series of a 2 pi functions. Let us sketch couple of functions and then we are f of x is equal to x. X lies between 0 to 2 pi. So this is the function I have written. This is the interval I have given. You are sketching this function and showing its periodic. That we have. Because today you are going to have a couple of functions. Make sure the interval which I have given, you are going to name it. This is 2 pi. 0, 2 pi. Then 4 pi. Then 6 pi. Here minus 2 pi, here minus 4 pi, and so on and so forth. And this is your f of x. Y is equal to f of x. Now when x is 0, f of x is 0. Then x is 2 pi, this 2 pi. F of x is 2 pi, so 2 pi is somewhere here, 2 pi. So since this is a linear function, it means your graph will be a straight line like this. Look like this. A linear function with the graph is a straight line. Now you are showing this to be periodic. It means you have to move the same graph backward and forward. Backward and forward. Backward and forward. So showing it's periodic. It doesn't make this is 4 pi, so the value must be 4 pi. No, you have to draw the graph in the given interval, which is this line. Now repeat this curve or the line backward and forward, next 2 pi length, next 2 pi length, next 2 pi length. And here, since it is periodic, so you will, like this, the graph is going to be some signals like this. You will see this graph repeats, this repeats. Let me change the interval now, so that can you minus pi less than equal to x less than equal to pi. Let me have the graph again, so that we can, because there are a lot of graph in this Fourier series, minus pi to pi. Whatever the interval I have given, minus pi less than x less than pi, you are going to take those interval on the x-axis. Not this time you are 0, 2 pi, 4 pi, whatever I have given. Again, this is 2 pi, then pi, 3 pi, then so and so forth, and this is your f of x. Here, minus 2 pi, here, minus 3 pi, and so on. Let me sketch. When x is minus pi here, f of x is minus pi, there. When x is 0, it is 0. When x is pi, it is pi. Look at that. I have minus pi here, fx is minus pi. I have 0, fx is 0. I have pi, it is pi. So again the linear function. So the graph is straight line passing through origin. Look at that. This is the graph, which is a straight line passing through origin. Now you have to show this to be periodic. It means minus pi to pi, the length is 2 pi. Again from pi to 3 pi, look at that, from this to this, the length is 2 pi, I have to have this, look at that, this. So if I move next, I'll have 4 pi, 5 pi, this is 4 pi, x-axis. So another 3 pi to 5 pi, the length is 2 pi, I'll have this graph again, look, this graph. Similarly, minus pi to minus 3 pi. Total length is 2 pi, this is the graph. So once a graph is sketched, you have to extend this graph backward and forward in another 2 pi length. So length must be 2 pi, from pi to 3 pi, it is 2 pi length, 3 pi to 5 pi, and same graph is going to be repeated.